Okay, greetings everybody. Welcome to another session. We'll start out with a quick announcement. Next week will be our final live stream for this semester. So this semester we've covered navigation problems for the past. So if you're interested in a particular topic for next week, please leave a comment in the chat box or down below and we can take a look at that. And then we'll take the summer off in the Northern Hemisphere anyway, and come back this fall for some new topics. So if you're interested in something else for the fall semester live streams, please let me know. So tonight we're going to be talking about maneuvering boards, and we're not talking about radar contacts like avoiding and intercept. We're talking about for navigation problems. So in essence, our boat is out here somewhere and we see a rock or a buoy or a light out there by radar, and we want to leave that at a distance of, say, 1 nautical mile. What course do we need to steer in order to do that? So we're going to use the maneuvering board to solve those kind of problems, including what time will be there, maybe if we change course at a later time, what our course to steer or our time is going to be. So if you are interested in the contacts type stuff for, vessel avoiding and intercept, what you can do is on practicalnavigator.org, you can find there's some chart plotting, rules of the road, celestial navigation, but there is a maneuvering board problem set that's free. So you can log into that, enroll for free if you want. They're also on YouTube, so you can check that out if you want. But any of those courses are available to you if you're looking for using the maneuvering board for like radar contacts and that kind of stuff. Also, if you're a student and you're studying for your exam, or you're at a maritime academy or something, and you want access to some of those other courses, just send me a note. We can work something out to give you the study resources you need to pass your exams for sure. Okay. So in this session, we're going to focus on using the maneuvering boards for situations like this, where we're trying to avoid a lighthouse, a rock, a buoy, something like that for a navigation problem. So these are specifically for Coast Guard navigation problems exams. They're not very hard, but I'll show you a couple different varieties of problems that we're going to work through. So in the video description box, or if you're following along with the notes, there's a couple of problems down there that we can solve together, and we'll get started right on the first one. So we're going to be mostly on the maneuvering board rather than on the whiteboard for this example. Okay, so our first problem is going to be asking us, in essence, we're steering a course of 019 degrees PGC, which stands for per gyro compass. And we notice that there's a light out there off our port bow, and we need to figure out how to pass it to port. So our first step for this problem is going to just be to lay in our course. So if we're on a course of 019 degrees per gyro compass, we can just lay that in directly onto the maneuvering board like that. So the maneuvering board is laid out with the 360-degree circle, and we just laid in our course. In the absence of any other information, we can't turn that gyro course into a true course. There's no kind of error or anything involved. So this is going to be it. So the next thing that it says is that we see a light 14 degrees on the port bow. So it's 14 degrees off the port bow. So we can plot that light at a distance of 15.3 nautical miles. So if I was to plot that out here, what we can do is we can set this maneuvering board to a scale of 2 to 1. That way every little tick mark in here stands for 2. Right? And then as we kind of look down at the bottom here for the maneuvering board, there's all these different scales. So we can measure these different distances for a scale of 2 to 1 or 3 to 1, etc., 4 to 1. All right, so it says that our light is at a distance of 15.3 miles. So on the 2 to 1 scale, I'll take my dividers and set this to 15.3 nautical miles. And it was off our port bow somewhere. So I'll kind of lay that in there as well. Then the problem said that we are, it's 14 degrees off the port bow. So if we're in a course of 019 and we're 14 degrees off the bow, it's going to be 5 degrees. I won't say true, but according to this maneuvering board. That means that the lighthouse is out there. So we're steaming along on 019. We see a light at a distance of 15.3 nautical miles, 14 degrees off our port bow. what course should we steer to pass 1.5 miles abeam of the light, leaving it to port? So our ship is going to pass this thing so that the light is on our port side at 1.5 miles. Well, what we can do is we can take our dividers and again, on the 2-to-1 scale, we can set them to 1.5 nautical miles. It's pretty small. And then from the light, we'll just swing out an arc 1.5 nautical miles. We don't need to do the whole thing, just the little portion that we're driving on. Okay, and then so the question is, what course are we going to steer in order to leave that buoy or that light 1.5 miles? And that's going to be our answer right there. Right? So we plotted the light, we created the arc 1.5 nautical miles, and then we laid in our new course. So it looks like it comes out to be about 0.11.5 degrees. And then so the problem stated that it was PGC, or per gyro compass. So we can just also call this per gyro compass. So that would be the course to steer to leave that light at a distance of 1.5 nautical miles. So that's representative of one of the types of problems you can see. And like I say, they're not too complicated. It's really just a question of using the maneuvering board. If you haven't done that too much, then that's certainly a skill you can have. So if it is brand new to you with the maneuvering boards, be sure to check out some of the other YouTube videos that I have regarding the maneuvering board itself, how it's laid out, all the different scales, how you can use it, including the speed, distance, time nomogram on the bottom, or check out some of the other videos that are available to you there for sure. Okay, so for our second problem, this was kind of what our first problem was, and our second problem is now just going to ask a different question. It's really done the same way, but it's asking about a time. How long is it going to take us to cover a certain distance? So this is a combination of a maneuvering board problem with a speed, distance, time problem. So this is the second one in the study guide or in the notes below. If you want to check that out, we'll go back over to the maneuvering board. Waste not, want not, right? We'll use the other side. This second problem, it states that we're steering a course of 231 degrees true, and a light is picked up dead ahead at 12.3 miles at a certain time. We change course, and then it wants us to know what time we're going to be next to that light. So our first step, just like the last one, is going to be to plot out our initial course. And so we were on a course of 231 degrees true. So we can lay that in on the maneuvering board. That's our original course. And we pick up the light 12.3 miles dead ahead. Right? So again, we're going to be on the 2-to-1 scale for sure, because there's only 10 miles in the 1-to-1 scale. So circle the 2-to-1 scale. And we'll set our dividers to 12.3 nautical miles. All right. And then since it was dead ahead, that's going to be the location of the light, or whatever we picked up. A light, it says in the problem. All right, so we've successfully plotted the location of the light. And then it says that we did this at 0038. So that's good to note as well. So we want to leave that light 4 miles abeam to starboard. So just like the last problem, we're going to set our dividers up to 4 miles, although it wasn't 4 in the last problem. And then we'll just kind of swing an arc out. And we want to leave it to starboard at 4 miles. So our ship is going to turn this way so that the light passes down our starboard side. So first of all, what's the course that we need to steer? Even though the problem doesn't ask for that, we'll just demonstrate it again. We'll create a tangent to that line there. So we're going to want to steer along that course, which looks like it's about 212 degrees or so. Right? So once we've done that, The question is actually asking what time will be abeam. So let's list the information that it kind of gives us. It tells us that the speed that we're going is 16.5 knots. And it says that it's asking about time. So speed, distance, and time are related. Time is going to be equal to distance over speed. Right? So if we can figure out the distance, then we're going to be good to go. And just in case that's a little hard to read, time is equal to distance over speed. And we've got a speed of 16.5 knots. So if we can find out what the distance is to cover, we're good as gold, right? And so the way to do that is to take our new vector, and we'll set up our wings here so that it's perpendicular to it. And we'll kind of scroll down until we encounter the light. That way we know that's going to be our CPA, or our closest point of approach, exactly when we're abeam. Right, so at 0038, we're right here. And at some other time, we're going to be right here. What time is that? That's the question. So if we can measure the distance between these 2 points with our dividers, and we'll look again at the 2-to-1 scale. You got to stay consistent when you're using the scale. It looks to me like it comes out at 11.5 nautical miles. Nautical miles. All right, so time is equal to distance over speed, which is going to be equal to 11.5 over 16.5. Which gives us 0.69 hours, or 42 minutes. Right? So this is going to be plus 42 minutes. And the question itself is asking about a clock time. It's not asking about how long it's going to take. It asks about a clock time. So 0038 was our original time. We're adding 42 minutes to it. That's going to get us to, oh, I'm sorry, this was, 0030. Well, it was originally actually 0338. I made a mistake there, sorry, if you're looking at the question. So 0338. So that gets us to 0420 for the time. Look at that, right? So we're going to be 42 minutes in the future. You're going to reach the closest point of approach to this light, and you're going to pass it down your starboard side. So that's the second type of maneuvering board question you can see on your exam for sure, where they're asking about time itself. So question number 1 and question number 2 were pretty much the same. They were just asking for different things, whether it was distance, bearing, or time. Right, so the third problem type that we have for tonight, or this session, is going to be one where we change course. So at time A, we see this thing. At time B, we change course to a new bearing, and then what is that course going to be? So it's just a little bit more complicated of a version than the previous problems we've already done. So not too bad whatsoever. All right, so if you're following along with the notes, it's problem number 3. You can look at that. It begins, you're underway on course 163. If you're on YouTube, it's in the notes down below there. We'll pop back over to the maneuvering board. Right, so this problem states that we're underway on a course of 163 degrees true at 15.8 knots. We see a buoy 5.5 miles ahead. We change course. What's the course to steer to leave this thing to starboard? Right, so we'll start off kind of the same way. First course is 163 degrees true. That's our original course right there. And we're going 15.8 knots. not necessary right now, but we see a buoy bearing 161 degrees true at a range of 5.5 nautical miles. So since this is all pretty close together, we can actually just use the 1-to-1 scale. So we'll set our dividers to 5.5 nautical miles. We'll swing that over here. And it says the buoy was sighted at 161 degrees true. So it didn't say like off our port bow, off our starboard bow. It gave a true bearing, so we can set our situation up like that. And that's going to be the buoy there, whatever the name of the buoy happens to. Okay, so we sight that buoy 161 degrees true at a radar range of 5.5 miles, and that was at 1319. So we sighted it at 1319. So then we change course at 1325, and what is the course to steer to leave that buoy abeam to 1 mile? So very similar to the last types of problems, we're going to set our dividers to 1 mile. This time we're on the 1-to-1 scale though. We'll swing an arc around that buoy. We'll do the whole thing. Right, so hopefully you can see that. That's 1 mile around the buoy. And it said we wanted to leave that buoy abeam to starboard. So actually we're going to turn across it and come down this way. So our new course is going to be somewhere over here. Not done from the middle, right? Because that would be at 1319. It says we changed course at 1325. So somewhere along here is going to be 1325, and we can put an X mark and then make the change from there. So if we're going 15.8 knots, and our time is, let's see, 1319 to, what's the new time? 1325. How many minutes is that? That is 6 minutes. 6 minutes. So this actually saves you a little bit of math, because the 6-minute rule says that in 6 minutes, the distance that you travel is equal to the speed divided by 10. So anytime you're traveling along, the 6-minute rule says take your speed, move the decimal place over, and you've got your distance. So our distance is going to be 1.58 nautical miles. So that's pretty cool. And they're actually just testing your knowledge of the 6-minute rule here in this problem. If you didn't know that, you could turn that into a tenth of an hour and then multiply this by 0.1, and you'd end up with the same thing. But in essence, what we need to do is find ourselves 1.58 nautical miles downstream. There's 1.5, 1.58. So this is going to be our position, our dead reckoning position at 1325. And that's the one that we want to change course from. We didn't change course at 1319. We changed course at 1325. All right, so off we'll go on that. We'll see what the course is to steer. 1325, tangent to our circle. Just like predicted, that's going to be our course out there. But you can't just read it off here, because we're not. That's not how the maneuvering board works, right? So we have to take this course and then parallel it over to the middle to read the actual value. So it looks like the new course is going to be about 145.5 degrees true is going to be the course that we need to steer, right? So the Coast Guard book answer is 145, and that's pretty close to it. You know, it took some liberties there with the process here. Right, so that's kind of the third type of problem that you can see, and that's really the last type of problem that you can expect to navigation problems exams. All of them are going to base you with you seeing an object out there. You want to leave it at a certain distance, a mile, 4 miles, whatever the case may be. So you're always just going to draw the circle around it. Pay very close attention to whether they want you to leave it to port or leave it to starboard, right? Because if, like in the last problem, it asked you not to open the CPA, but to actually cross over to the other side and solve it that way. So then once you have that information, they can ask you one of three things. That's 4, I guess. They can ask you, what course do you need to steer? They can ask you, what time will you be there? Or they'll say, you change course later. Now what course do you need to steer? So one of those 3 types of questions is all you're really going to see on your nav problems exams. All right, so I'll kind of leave it there. That's all we really have in this session. It's just 3 types of problems that you can see on the maneuvering board. Like I said, if you're interested in a topic for next week, please leave a comment down below and I'll take a look at that. Otherwise, I'll just pick something fun. And then also, if you're interested in the maneuveringboards.org or my other videos on YouTube have what I think is a pretty good set of videos for maneuvering board stuff, particularly if you're in the Coast Guard studying for your service-wide exam. That's what they're designed for. But Alex is asking, is the radar board the same? It kind of is, right? So this maneuvering board, the green one that I showed you here tonight, is very similar to like a plotting sheet. So some different radar schools have like a white version of it with black concentric rings around it. Same exact thing. You can use it the same way. The maneuvering board is actually really versatile. You can use it to calculate the wind. If you're launching helicopters off your deck, you can use it to pick what course you need to steer to have a desired wind of 30 degrees off your port bow, for instance. You can use it to avoid contacts, radar contacts. You can use it to intercept them for like law enforcement purposes or search and rescue purposes. And then finally, like we did tonight, you can use it for navigation problems like avoiding lights at a certain distance abeam. Right. Adrian also asks about some of the notes that I've passed along to some other folks. Yeah, if you've got questions, if you're studying for your exam, please shoot me a note at chris@practicalnavigator.org. I'd be happy to share some resources with you in a Dropbox folder to help you for your studies or answer any questions. I don't necessarily have a desired wind class, but I do have a video on YouTube that's up already if you want to just check that out. I think it's in one of the links down below that you can get your desired wind right from there. So definitely. So, all right, you're welcome, Alex. No worries. So I'll stick around for a couple questions if there are any other ones regarding the maneuvering board. And then otherwise, we'll see you next week. Okay, this is Chris signing off. Have a good evening. Like I say, if you've got some questions about maneuvering boards, check out down below. There's a couple of links there. And then in tonight's video, we talked about navigation problems specifically. So, okay, take care.